Hello everyone, welcome to a new Java game programming tutorial. This is the first one I'm doing that's not actually for the AP students. What happened was I posted this video 7 hours and 20 minutes long of all 12 of the lessons I've had so far. And I also posted this link on the Game Dev Reddit, and people have been liking it. I've not got a single dislike yet. Please don't be that first person to dislike. Probably shouldn't have said that because there's probably some of you are probably trolls out there. Um, but anyway, yeah, it's been well received. I haven't actually got any comments on here, but I did get a few on Reddit. Now, somebody is asking here, and actually at the very end of this video, I did say if you have any, if you want me to make a video continuing this, just let me know. If you want anything specific, just let me know. This guy on Reddit said he's extremely new to game development. This might be a noob question, but will the beginning stuff part work for a 2D platformer? And what's the difference between code for that game and a 2D platformer? So I said I'd make him a video, and this is that video. So it's actually really easy to make the engine we have so far work for a platformer. I tried. My whole goal in the whole thing we have so far was to make it pretty easy to do a lot of things in this engine. So what we're gonna do is this is gonna be one of those kind of up to you type of lessons. A lot of them are like that, like the utility series and stuff like that. So it really is up to you, excuse me, whether you do this lesson or not. But I would still recommend creating a new copy of your workspace and calling it maybe workspace platformer or something, because we are going to be changing a few things that you might forget about, and it's just easier to have two copies anyway, and this is the backup if anything goes wrong. So I do that quite a lot when I'm programming. It's a good thing to do. So let's open up our new workspace here, and what we're going to do is we're going to go ahead and first of all make sure this all works. I'm pretty sure it'll still all work. And by the way, for those of you, I didn't really explain in the 7-hour video, but I do have two things in Sublime Text to help me out with this. One of them is automatically an option. If you go to Tools and Build System, there is Java C, and that'll be there. I also made a Run Java build system. If any of you use Sublime Text and you want that, what I do is I do Control-Shift-B, and this menu comes up, and I just select which one I want to do. And I've gotten really good at doing that really fast. But if you guys want that, just send a comment, and maybe I can put that on my website or something. So anyway, this is what we have right now. We are moving around, and we have our tiles that we can place. And yeah, cool stuff like that. So let's think about things we'll have to change to make this a platformer. So first of all, we're going to have to make it so that the player can't just move all over the place. Maybe we make it so he can jump and has a velocity downwards, and we can mess with acceleration and like time management and stuff like that. So that'd be cool. We also want maybe a background, so something that is behind us that will hold on, yeah, this is our workspace, sorry. Something behind us that will move when we move left or right, and maybe the level will end and it'll stop moving, but our player can move all the way over there. All cool stuff that is more than possible. But for that background thing, what I think would be really cool is to have an actual file that represents the entire level, and then you can run through the level like this. So I think that'll be something that would be really cool, and I think we should do that. The only problem is we don't actually have and this is entirely optional as well, but we don't actually have a way to render that right now. We can't render a section of an image without doing a bunch of other stuff, but that's a really easy method to create. So if you go to Render Handler, go ahead and open that up. Make sure I'm in the right place. So, and if we go down here, we can see you can see Render Array right here. Okay. And we're just going to go ahead. This is the very, like all of the other methods, if you don't remember, like render sprite and all of that, they all end up calling render array in some way or another. So this is kind of what we need to deal with. So what we're going to do is we're going to go ahead and copy this method so we can refer to it, but we're not going to use it in its entirety. And we're going to, let me just zoom in here because it'll help you guys out a little bit. We're going to change a few things here. So we have the render width and the render height, right? Now that's the width of what we're rendering and the height of what we're rendering. So I want to have that still, but I also want to add two more parameters. I want to have parameters image width and image height. And image width and image height is actually going to be the actual height of the image and the actual height of the or actual width of the image as well. So for example, like this image player.png is actually 160 by 104, but realistically we are rendering these little parts of it. Okay, to render each, whatever player he's in, and we're doing that using sprite sheets and splitting them all into sprites, which is still a really good way to do it. But I think this is another cool option. So image width, image height, render width, and render height. So we have all those parameters now, and another few parameters. I'm actually going to first of all find a good place here to press enter, and then tab this in so it's lined up like that. I also want to add two parameters here for the x position, the x offset and y offset into the actual image as well. So I want to have x offset and int y offset. Okay. So now what we've done is we've made it so we can take any big sprite image, or it'll always be brought down to a collection of pixels that we're rendering, and actually take a section off of it. So I actually think one thing we should do here before we even get started is make a good comment here, because one of those comments, so we can explain what each one of these parameters is actually doing, because it can be a little bit confusing when you look at them, and this is just a good way to get around that, and it'll maybe you understand it now, but you might not in the future. So the render pixels is actually the pixels to render, or actually generally just the pixels of the image / sprite. We'll go ahead and say entire pixels of the image / sprite. / rectangle / etc. Alright, and then the render pixels, or sorry, image width is the width of the entire image. And actually, I can go ahead and just say image here because, I mean, at the end of the day, it's always going to be an image. Image height is the height of the entire image. Okay, so now render width is width of the image to render. And then render height equals height of the image to render. And you know what? Now I'm looking at this. I think it might even be less confusing if we were to go ahead and cut these. I mean, it's up to you. You could. Actually, I'm gonna do this. Yeah. So what I'm doing here is I'm putting x offset, y offset, render width, and render height at the end, so it makes a little bit more sense, because it's like we have the x and y and then the width and height of whatever we're rendering, so within the entire image. So that's at the end. So let's go ahead and do our comment here in order. So we have image width, image height, x position equals position position of image on screen. Okay, and then y position equals x position, y position of image on screen. Well, not the entire image. Maybe we'll say x position of render on screen, of the render. Let's say the render. Okay, x position, y position, x zoom is the horizontal zoom, and y zoom equals vertical zoom. That's pretty easy to understand, I think. Fixed is should offset by if the render should offset by camera position, and x offset equals offset into the full image to render, into the render, say that, x. You know what, I'll go ahead and say horizontal offset into the render, and y offset equals horizontal offset into the, actually I'll say image, because this isn't into the render, it's into the image. Yeah, it's a little, I mean, I'm just, you don't even have to do any of that, but I think it's easier, so you can look back and see what all of these variables actually mean. So we've done all that. Now let's actually implement this. So first of all, the pretty easy thing to do is what we're doing here is we're actually looping through the render, and then not only down here, we actually increasing by the x position and the x zoom position, because we're still going to have zoom. So what we're going to do here is we're going to do y equals y offset, and y is less than y offset plus render height. Okay? Because we're rendering that section of the image. Render height is still the same. X offset, x is less than x offset plus render height. Render width, I mean. And then we need to actually do some more offsets down here. So we have using the set pixel method, which is actually down here, and it takes pixel, x, y, and then if it's fixed. So the pixel is actually still the same, except we're changing render width to be image width because we this is the width of the image. Because remember, to get the pixels of an image, is the x position, so from the left times y times the width of the image, and that we can't change that. It was render width before because we changed what render width means. Render width used to mean just the width of whatever we're rendering, which it still does, but image width is the actual width of the image. I'm sorry that this is so confusing because I'm not explaining it well. I apologize. But if you have any questions, go ahead and leave a comment. So anyway, that's the pixel of the image that we're rendering. And then the x position is x, and we actually want to subtract x offset from this. So it's x minus the x offset times x zoom, okay? And we want to do the same for y, so it's going to be y minus y offset times the x zoom, or y zoom. And that should be it. So we've implemented that in render array. We have new parameters for this, and the other render array is still going to exist, okay? Because that's kind of just like render, you know, these pixels of the screen, and it's not too confusing, but this one's a little bit more confusing. So actually, in order to actually use this, I'm going to make render sprite, another render sprite method that takes a few extra parameters. So we have sprite, we have int x position, we have int y position, still have all these are the same, boolean fixed. The only other thing we're going to do here is we are going to ask as well for int x offset, int y offset, and int width, int height. Now, why am I saying width and height, not just render height and render width? Because we don't have an image width and image height. That's actually, we can get that from sprite.getWidth. So, yeah. Let's go ahead and paste in this render array method, and we're going to call this with render pixels. The image width is sprite.getWidth. And actually, render pixels is sprite.getPixels. Image height is sprite.getHeight. And then we have the x position, the y position, the x zoom, the y zoom, all the same, whether it's fixed or not. X offset, y offset, and then width and height. Alright. So there we go. So another thing I want to do is, that I almost forgot, is we are currently copying a lot of code, right? We copied this entire method down here. Now what if we, actually, for this render array method, it's less complicated as far as the parameters go, so I don't want to just entirely get rid of it, but why don't we go ahead and call this method, right? And what we'll do is we'll go ahead and pass in the render pixels. The image width is render width. The image height is render height. The x position is still x position. Y position is still y position. We have x zoom. We have y zoom. We have fixed. And then the x offset is going to be 0. The y offset is going to be 0. The render width is going to be render height, or render width. And then the render height is going to be render height. So what we've done pretty much is we're doing everything we had in this method, but we're calling this one instead, so that we only have one method because otherwise we're just copying a lot of code, and this looks a lot cleaner, and everything points eventually to this method, which I guess eventually points to setPixel. And setPixel, if you guys don't remember, the reason why we have this in the first place is, first of all, it offsets by the camera. Oh no, it doesn't. Does it? Yeah, it does. It offsets by the camera if need be. But it also makes sure that the pixel actually fits in the pixels array. So it does this very easily by just making sure that the pixels.length is greater than the pixel index, and stuff like that. One thing it doesn't check for to see if it's less than 0. I'm not sure. Maybe I don't know. We'll forget about that for now. I guess it's pretty hard for that to happen, for something to be less than 0, and the error will probably be in fact, I think I know why I did that, because if there's a pixel that's less than 0, there's probably something else terribly wrong, and it's best for you to get an error to figure that out. So yeah, that's probably why I did that. So let's go ahead and run this, and this should work the same way it was before. because everything's just calling that method with no offsets whatsoever. But now we have that, so that's cool. And another thing I want to tell you guys as well. Another thing we just need to fix that I almost forgot about is this. Now, set bounds 001800. What if I told you that it's lying to you? Well, not necessarily. This is setting the bounds for the entire window, but it's not setting the bounds of the canvas. And that's actually a huge problem. So, and the reason why that's a huge problem, and that I for some reason did not tell you guys this before, I don't know why, I just somehow forgot that the window and the canvas were different things. I don't really know. I apologize. But what we're going to do is we're going to go ahead and set the size of our canvas. And we're going to get rid of the set bounds. We're actually going to comment this out so that you guys don't get confused. And we're going to do canvas dot set width 1000, or is it set bounds? I think it's just set bounds. Yeah, it's the same method. Set bounds 001800. So the actual boundaries of the canvas is like that. And this renderer, where we're actually, this needs to be canvas.getWidth and canvas.getHeight, okay? So we set the bounds, and then actually down here, well, after we actually add the canvas, which is there, we want to do pack. We want to call the pack method of JFrame. And since, remember, this is extending a JFrame, this is the JFrame. So what it's doing now is creating a canvas. Oh. Then height cannot be less than 0. Let me just check here something. Maybe I did something wrong. Alright, we're going to do this. We're going to go ahead and do, we're going to call this before we add it to our frame. Maybe we need to do it here. That might be why. There we go. So call pack right after you add it, and set location relative to null. Let's go ahead and put that here. So I've got the order sorted out now. So now that should be in the center of the screen again, and it'll all be fine. And now the actual width of the canvas is 1000 by 800, but the width of the frame is going to be bigger. So, by the way, okay, so just in case you're confused still, the width of the canvas is the actual area in which we're rendering the screen. So this kind of area where our mouse is highlighting. The width of the frame includes this top bar and also like tiny bits of border on each side, which will be different for each system. So it's very important that we make this distinction now, because I really do apologize that did not happen earlier. Maybe I'll make like a huge notice, or I will comment somewhere on the video, the big 7-hour video where that happens, or I don't know. We'll figure something out. But I do apologize for that. And yeah, maybe I'll link this video to this exact spot so people understand to make that fix. But that fix is done now, and make sure you also do canvas.getWidth and canvas.getHeight when you're creating the render handler. And yeah, that should be fine. So we've made that fix. So now what we're going to do is we're going to go ahead and open up our workspace here, and we're going to go ahead and make a new image, and this is going to be the background of our level, okay? So what we're going to do is we're going to go ahead and do File, New, and the width is going to be, well, we'll go ahead and make it like 5,000, okay? And the height is going to be the height of our screen for now, and actually, you know what, we'll make it a little higher than our screen. We'll make it 1,500 so we can jump up, maybe. So now what we're going to do is we are going to go ahead and just like fill this with like a grayish color, and I'm just going to go ahead and add some noise so I know that stuff is moving. You guys can make your own background for the game as well, but this is good enough for me for now, and this is what I want to save it to. So I'm going to call this background.png. Okay. And it's saving. So background.png is right there. So now what we're going to do is we are going to go ahead and try to implement this. So the best way to do this, I think, would to actually be to completely rewrite the map class. Sorry, that's my notes. And I always want to get that up so I don't make any mistakes on video. Even though I still make mistakes. So what we're going to do now is we're going to, first of all, remove things that we're not going to use in game. Just comment them out for now. So tiles, I'm not going to use. Map, we're not going to use right now. Actually, we'll figure that later. So, and then the GUI, we're not going to use. Let's comment all of this out, and then let's get rid of this and make it so we only have one object. So now if we render, we should have a blank black screen, except not game.java 182. What's not working? Oh, we're rendering the map still. Don't render the map, and don't update the map. So if we just control F map. We don't want the map set tile, map remove tile. Sorry, you know what? Okay. I've changed my mind. Control Z a bunch of the stuff you did except for the GUI thing. We're going to keep the map, and we're going to keep the tiles. So now when we run, we're having trouble. 185. Oh. You also need the objects to be size 1s because we only have the player in there now. And yeah, here we go. So the GUI is gone. It's pretty much all we got rid of there. So just comment out all the lines to do with GUI and set the objects to 1, not 19. I must have clicked something. So there we go. Now what we're going to do is we're going to go to here, and we're actually going to rename the map we have to map old because we're going to recreate map, and we're going to create map.java again. And what we're going to do here is we're going to open up the new map.java, and then we're going to open up mapold.java, and we're going to put that over here so we have that, okay? And pretty much what we're going to do now is we're going to make it so that we render a background. So that's the first thing we're going to do. So public, we're just pretty much a lot of the stuff's going to be the same, but which we will and probably end up copying over. But as we do all the time, it is public class map, and up here we're going to have private sprite background. So that's going to be our background, and we're going to have to render that. So let's go ahead and do private. Okay, now what we're going to do is we're going to create our constructor. So public map, and it's going to take right now just a background, and this dot background equals background. Okay, and then we're going to create a render method again. So public void render handler renderer xzoom, or sorry, int xzoom, int yzoom, just as before. Make a space there. And what we want to do is if you remember what we were doing with player originally, and we can use the same thing we were doing before. So if I open up the player class here, each time we move, it updates the camera. So the camera itself in the render handler gets updated. So we're gonna go ahead and render the background depending on where we are. So renderer dot get camera, and that's a rectangle. So we're gonna go ahead and call this a rectangle. Rectangle camera equals renderer dot get camera. Okay. And we're going to go ahead and just do renderer.render sprite. We're going to render the background sprite at 0, 0. Let's go ahead. I forget the parameters entirely. So what we're going to do is we're going to go ahead and go to render handler, go to the render sprite line with the offsets, because we're going to be using those to render our background. That's the reason we made that method. And we're going to paste this all in there. And let's see, when does it stop going? It was off screen there, so tab that in. And actually this is, even though I could just make this a bigger screen, I feel like this is a better way to do this. We'll do it there as well. Okay, so the sprite is background. The X position is just going to be 0 because this is actually the position of what we're rendering. We want it to actually fit the entire screen. So I can tell you that that's 0, that's 0. The width is going to be camera.width, and the height is going to be camera.height. Okay, those are givens. Okay, the zoom is going to be 1 because we're not dealing with zooms right now. In fact, we could. Well, no, I'm not going to get rid of these because we also are going to be rendering actual objects in the map, and X zoom and Y zoom, you could still use those if you want to, but it's entirely up to you. You could get rid of them here if you just want to have everything the size that it would be in the window, but then remember, the reason why I implemented X zoom and Y zoom in the first place, which I don't think I actually ever said, was because if you have screens with different resolutions, you might want to zoom different things in depending on the screen resolution. So don't necessarily just remove zoom from your game because you think you don't need it. If you want your game to ever be played by other people, these are things that can be very important. So think about it before you move stuff like that. But for right now, we're going to deal with the zoom of just 1 for the background. Boolean fixed is actually going to be true. We do want this to be fixed. The X offset is going to be camera.x. The Y offset is going to be camera.y. And then the width is going to be camera.width and camera.height. So that is it. So let's go ahead and compile that. And we're going to see that private sprite. Oh, oops. I put this outside of the class. I've never done that before. Well, I might have at some point. The error that I was expecting was that, not that either. Missing a semicolon. The error that I was expecting, which I'll probably get if I render this or compile this, is that we need to create our map with the new types. So we need new map, and we're going to pass in a new sprite, which is going to, and remember there's a sprite constructor that we created a long time ago, which I knew would be useful, that would just take a buffered image. So what we're going to do is we're going to go ahead and do new sprite and then load image background.png. Okay. And then save map doesn't exist right now, so we can go ahead and comment this out. What else doesn't exist? Map set tile doesn't exist. This is why I wanted to comment these out. I remember now. That stuff doesn't exist, and we can re-implement that later if we want to. But now if we go ahead and run the game, okay. Maybe there was a problem with the negatives. So I think I know what the problem is. What happens is when we move our player to the middle of the screen, this whole thing gets moved down like that. Because originally our player, I believe, was positioned at... well, it's going to try and put the player in the center of the screen, right? Which means that if the player is at 0, 0... I also realized that we didn't actually set the correct... let's go ahead and do 0, 0, and this isn't the correct size for the player. I think it's 26 and... Hold on, let's look here. 20 and 26, at least for this player. Is that width and height? Probably. 20 and 26, so we're going to do that. And we'll go ahead and set the X to be like 800, and the Y to be like 500. There we go. So now we are in the game, and if I use my arrow keys, and oh, that looks really weird because of my, and that's because of the sprite, not because of anything I did. Now, as soon as we go out of boundaries, it's going to crash. So that's the next thing we need to solve, and that'll be going to the player. So first of all, what I want to do is change how player moves. So, well, actually, this does solve one problem at a time. Let's go to update camera, and update camera is going to change to make sure that we don't go out of bounds. So let's go ahead and just set an integer here into x equal to player rectangle dot x minus the camera dot width divided by 2. Okay, and that's what we had down here. And we're just going to go ahead and make sure that if x is less than 0, x equals 0. And if x plus camera dot width is greater than the width of the map, which we have to get. So let's go ahead and make a public void get max x, or I guess I should say get width. Would make more sense. Return, or it's not going to be a void, it's going to be an int. And return background dot get width. Okay, and now the player's going to have access to this. We have map and rectangle camera, and then we need to pass in a map here, where we're actually calling the method, and then this method needs a map. And actually, maybe we can go ahead and just make a, if we don't have a game.get map method, okay, we don't, we'll create one quickly. So public map get map return map. So we can just go ahead and do game.get map here. All right, simple enough, no semicolon. Greater than map.get width. and then x should equal the maximum x that we can make it. So that'd be map.getWidth minus minus the width of the camera. I think. Map.getWidth minus, isn't it camera.width divided by 2? Let's try that. And then camera.x, we're not gonna, well, we'll also do the same thing with y in a second, but we're gonna try x first. So we'll just comment that out. We won't change the camera y, but camera.x is gonna equal x. So pretty much what we've done is we're changing it to try to put the player in the center of the screen, at least on x so far. But if the x is less than 0, we're going to set it equal to 0, which was an easy one to change. But if the x plus the camera.getWidth, so pretty much if the right side of the rectangle that represents our screen is greater than the width of the image, then we want to set it to the maximum that we can. This is a method. So we're going to compile that and then run our game. And what should happen now is if I go to the left, as you can see, the screen stops moving, and right now we're not changing the Y, so that's not going to move. The screen stops moving, and as soon as we get to the middle of the screen and we can move the level, it'll start moving. And I want to make sure it works at the end as well here. So we did have a while to walk, I think. Whoa. Interesting. Oh, that's not what I wanted. Oh, wait a minute. Yeah, because it's talking about the left side of the rectangle. Okay, so it would be, if x plus camera.width is greater than map.getWidth, x is equal to map.getWidth minus camera.width. So now we have to do that whole thing again. I'm going to take a sip of my Diet Coke here while we're walking. Who does not sponsor me? I just like Diet Coke. Not sure if any of you would have possibly thought that I would have had a sponsor at this point, but alright. So, there we go. That seems to be working. So when we get to the edge of the map, the camera stops. So now let's go ahead and do it for y. So into y is going to be player rectangle.y minus camera.height divided by 2, which is how we centered it originally. And if y is less than 0, y equals 0. And if y plus camera.height is greater than map.getWidth, return background.getHeight. So we have to make that method. Not getHeight, or getWidth, getHeight. Then y is equal to map.getHeight minus camera.height. And then finally, camera.y equals y. And actually we'll move this camera.x equals x down there just because I think that'll look better. And there we go. So now we should, and just to test this, I'm going to implement velocity and stuff soon. But now, actually, another thing I want to do quickly is set, or back here, set our starting position to 0, 0. So that means we should start in the top left of the screen. Yep, we're up there. Which is not, really we should start all the way down here. But that's what we're doing for now. And actually, what we'll do, okay, just thinking here for a second. What we will do is set y, well, okay, hold on. Let's just go ahead and hard code it for now. Set y to be 1500 minus 26. I'll just write that in there because it's a one-time operation and I can look at it later and understand it. And then we isn't there's zoom as well. That's right. 78, so. I think the zoom was 3. We made it. Yeah, there we are. Okay, cool. So now we start at the bottom, like that. And as you see, if we go up, the camera will stop there. And obviously, This is a platform where we don't actually want the player to be able to move like this, but that's the next thing we're going to do. And in fact, we can do that now because that looked like that worked. So what we are going to do is change a few things here. So to make this a little simpler, we're going to go ahead and change... let's see, where do we have speed? I think speed was here. That's game, not player. Speed is up here. Okay, so platformer movement. I just caught that and I'm gonna place it here because we're gonna change a few things. We're gonna have speed, and I'm gonna go ahead and well, let's make it like 15 or something. We'll change it up, make it a little bit more faster than it is right now. And then we're gonna have jump speed, which I'm gonna go ahead and set to a way bigger number, like 40. Okay. So and then other things we want. Some more things we want is we want to have some velocity and acceleration. Now, I think the best way to do velocity would be to we could just do like y velocity, the velocity that we're currently, because pretty much. Okay, let me explain what I'm trying to do. I'm trying to make it so you can jump and then it'll fall depending on how long you've been in the air, kind of like, you know, normal life. Just in case we want to do something later, we're actually going to create a new class here called Vector2, and we're not going to do too much with it for now. But Vector2 is pretty much just like a rectangle, except we just have x and y. And it's going to deal with floats instead of integers. So we're going to go ahead and just create this class very quickly. Blah, 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 I can't speak. Public class Vector2. And this is going to have public float x and y. So if you're wondering what a float is, it's just, in order to explain it the quickest I can, it's just the most efficient way to deal with decimals in Java and in other languages as well. That's pretty much all I'm going to say. So all you really need to know is that it's a number with a decimal, just like a double, except it's a little bit more efficient. Even though I guess efficient isn't even the way to explain it. You can look it up if you're interested. But we're going to go ahead and make a constructor here. A default constructor will just set x to 0 and y to 0, which I know that's what they'll start as by default, but just seeing that there makes it easier. And then public vector2 float x, float y. We'll do this dot x equals x, this dot y equals y. Okay. And that's all we're going to have for now. But what we're going to do is we're going to go ahead and do private vector2 velocity equals new vector2, and just using the default constructor. So that's our velocity in x and y, dealing with floats. So some more floats we're going to have is acceleration. So let's go ahead and make a float for gravity. I'm going to call this it's just going to be called gravity, and it's the amount of force pulling us down. And you could be like, okay, I'm going to make this 9.8 like I learned in physics class, but we're going to make it like 1.5 because we're dealing with a lot smaller space. So private float gravity, and then private float acceleration equals, and acceleration is actually just whenever we click a button, how far we move. And in fact, that's just speed, I think. Yeah. I'm not sure what I'm doing. Okay, so it's just speed. In fact, we'll make that... well, let's make it 10. I don't know. I think I was confused about something that I had in my notes, but that's just going to be speed. We're going to have speed, which is how much we move to the right and how much we move to the left. Jump speed, which is when we press the up button and we're on the ground, we fly upwards. And then gravity. So the first thing we want to do is... the directions we're going to have. Well, when we press up and down, I don't want the sprite to actually look up and look down. I want it to move in whatever direction it was moving originally, so we can just do that by commenting out 2 and 3, which means that if we were to run the game now, when I go up, it'll just do the left animations, which is good because that's the way we're facing. And maybe I guess we could do it if you were to jump just once without any horizontal velocity. Maybe we'll do like the forwards animation. That could be something we could do. So that's an option, but we need to actually code that first. So yeah, that's pretty simple. Y minus equals jump speed, and actually what we want to do is deal with the velocity vector now instead of all this stuff. So pretty much what we're going to do is velocity.x, instead of instead of just changing it here, we're going to do velocity.x equals negative speed. Okay, we're just gonna set it to that because I don't want it to be like you're on an ice rink or something. If you want it to seem like you're in an ice rink, you can have like acceleration and make it so the player, whenever he presses right, he starts moving very slowly, but then gains velocity. But we're just gonna go ahead and set it. We're not gonna do minus equals. We're gonna go ahead and set it to negative speed if we're going to the left, and then velocity dot x is gonna be equal to speed if we're going to the right. And then I'm gonna comment this stuff out for now. But we'll figure that out later. So at the bottom here, what we're going to want to do is we're actually going to want to change the velocities. Well, actually not change the velocities, just increase player rectangle.x by velocity.x, and then player rectangle.y by velocity.y. Okay? So now we want to do some stuff here. So we want to figure out... we want this to be able to decrease or increase given that we are sitting on the ground, right? We don't want to be able to move right or left if we're in the air. Or I guess we could do that, but it would just be... No, that's fine. Pretty much all I want to do is make it so that there's gravity. That's what we'll do right now. So pretty much if player rectangle.y, so if our y position is less than the... is less than or equal to a minimum y position, which is pretty much whatever platform we're sitting on. Or for now, that can just be equal to the bottom of the screen. So if game, we're just going to do game.getRenderer.getCamera.height minus the height of the rectangle, the player rectangle. So if player rectangle.y is less than y minimum, then velocity.y is going to be plus equal gravity acceleration. Wait a minute. Less than y minimum. Oh, wait a minute. Yeah, I get this. So I was just trying to remember what this was. So this is the height in which once we reach this point, we don't want to increase more by gravity, otherwise the player will just continuously falling until he's way off the screen. So this is the player rectangle.y if it's because remember y goes 0 at the top and it's like bigger at the bottom. It increases as you go down. So if it's less than this, that means you're not sitting on whatever surface you're talking about. And this y min variable, once we implement different platforms and surfaces, will be equal to whatever surface the player is standing on minus player rectangle.height, so it's talking about the top left of the player. So velocity.y plus equals gravity acceleration. And I actually think we also might need to take into account the zoom here as well. Else, make this like that. Velocity.y is going to be equal to 0. Okay? And then player rectangle.y is going to be equal to y min. And velocity.x is going to be equal to 0 as well. And the reason we're saying that to 0 is because if you're hitting the ground and you're not moving, I want to stop. But if you pressed left and or right and up at the same time, I want you to still be moving in that direction until you stop that, to make it a little bit harder to control movement while you're left and right movement when you're in the air. Could not find symbol gravity acceleration. I just called it gravity, didn't I? That's why. I don't know why I said gravity acceleration there. So. Oh boy. Okay. So, what did I do wrong here? A few things aren't happening. First of all, it's... Maybe I did the y min wrong? Oh, I don't think I did. We didn't do anything here, which might be why. Let's go ahead and do velocity.y equals... Or, yeah, we want to go ahead and check to make sure we're on the ground. So we're going to go ahead and do Boolean on ground. And this will be after, actually, this part. So Boolean on ground is going to be equal to player rectangle.y equals y min. So if the player is right at the minimum, then we're going to, so if we're on the ground, then we are going to velocity.y minus equals jump speed. Huh? 86. Ungowned. Nope. And that should make it so we can now jump. And as you can see, it seems like we're jumping by quite a lot, actually. We're going right up to the top of the level. But the other thing I'm confused about is why we are up here. So let's figure that out. And actually, I think I know why. I just thought about it. We're getting the height of the camera, not the height of the map. I forgot about that. Dot get height. So now what should happen is we should be, yeah, we need to implement zoom as well, which is a problem. And maybe we can do that. Well, I don't want to necessarily do that with player rectangle. I'm just gonna go ahead and do that. Times game dot y zoom. Do we have methods to get that? Maybe it's get. Although to be honest, I think I might just do public final int y zoom and public final int x zoom and y zoom. So this should be, we should be able to get that now. Okay. So now we're at the bottom there, and we can jump to go up there. And as you can see, we can control it in the air. Now if I press up and right, we move like that. Now if I hold it down, it makes really no difference. It just depends if I change it or not, because if I change it, we go in that direction. This is kind of like a static-y type of Mario World type of side-scroller, if you're Super Mario World. If you, you want that kind of movement, then you can mess with the speeds, like the movement speeds and jump speeds, to get what you want. In fact, probably what I'm going to do right now is decrease the jump speed to more like 25, maybe 30. But whenever you change that, for a while it'll just feel like you can't jump that much at all, and you just kind of have to find that happy medium. And you can make these floats as well if you want, if that makes your life easier, if your happy medium is between a certain two integers. So so yeah, we can jump and stuff like that. So the next thing to do is actually implement, well actually first of all, I want to make it so we can't go out of the actual map boundaries. So and the way to do that is to simply go to player again. And after we've done all this testing at the end here, before we actually change stuff, we want to make sure that we're going to do int x. We'll do the same thing we did with camera. We'll do int new x equals velocity, or player rectangle plus dot x plus velocity dot x. And then int new y equals player rectangle dot y plus velocity dot y. And if new x is less than 0, new x equals 0. If new x is greater than map, or game.getMap. In fact, what we're going to do is going to go ahead and create just a variable for map here. So we can just use that. And then we can go ahead and remove that and put map there instead. If new x is greater than map.getWidth, then we want to go ahead and set new x equal to map.getWidth. Actually, map.getWidth minus player rectangle dot width times 3, because that's the zoom, or times game dot x zoom. New x equals map.getWidth minus player rectangle dot width times game dot x zoom. Okay, and then some more stuff here for y. If new y is less than 0, new y equals 0. And if new y is greater than map.getHeight minus player rectangle dot, wait a minute. I was just thinking about this. No, it's fine. Player rectangle, I'm just, brains all over the place today. That's all we need, yeah. And then new y is equal to this as well. Okay. So that's pretty straightforward, and then we just go ahead and do player rectangle.x equals new x, and player rectangle.y equals new y. So now we should be able to go out of boundaries. Map equals possible lossy conversion. That's correct. You were correct with that statement. Good Java compiler, sir. Float new x and float new y. It's the easy way to fix that. And then we have a more lossy conversion. No, that's not the easy way to fix that. The easiest way to fix this would be to cast to int. And maybe we can do this in a... Well, we'll just cast it. Query around it and everything, but this is just easier. Don't need that much precision. So now we should be able to go out here. Cool. And I can't really test over there, but I'm sure it'll work. Let's just try the right side, because I used the same code for... Well, just to make sure, I did use Y zoom, not X zoom, right? Even though they're the same for me right now. Yeah, I did. Okay. Yep, okay, so we can't go out of the boundaries of the level. And I'm just going to hop my way to the left. No, I don't have to do that. So we have done that now, so that's pretty cool. The next thing we can do is implement a level. Now, this is when I'm going to talk to you and ask you exactly what you want. Now, in my notes, actually, I implemented it, and in fact, I can show you here. I'm running the game from my notes right now. I implemented it with the with the SDK we have right now, so that you can actually place tiles in places. Now, I can show you guys how to do this, but I just figured out, or I just thought, there's a way easier way to do this. Why don't we open up our background.png, right? And then create a new layer. And this layer is where we're going to put all of our platforms and stuff, and you know, I'll just kind of place them here. You know, you probably want to make them look a little nicer. So pretty much, if you have like a level designer on your team, or if you are the level designer, you can have him just make his level in whatever image editing program he or she wants to use. So now what we're going to do is we're actually going to save just that layer as a new image. So let me go to workspace. We're going to set this to be level platforms, platforms.png. Platforms.png, okay? And actually another thing we want to do is we want to, let me just, implement a alpha color, or something that we want to be alpha. So let's go to player.png would have the alpha color, just because image is not recognized. What? There we go. That's weird. Color picker, that, and then paint bucket. Just to be sure, I'm going to select everything, this alpha, and then paint it. Okay. And then we can save that as platforms.png. Okay. So now in the map's going to take two parameters. It's also going to take platforms. Now I know what people are going to be thinking already. It's like, well, how are you going to make it so the platforms do things and you can sit on the platforms? Well, first of all, what you could do is we could make it so that, well, this is what I will be doing. I'm going to teach you guys how to do raycasting, right? Which is pretty much where all the platforms are going to be rendered into, they're going to be put into a separate array, and there's going to be an array that starts at the top, or where starts at the bottom of wherever the player is. So let's say the player is right here where this P is. Well, we're going to go ahead and do this thing that's going to raycast downwards, and when it hits the platform, it's going to give the Y position of that platform, so that the new ground position will be wherever that ray hits, and it's going to hit the platform, and that's where the player is going to fall and touch and land, and it's going to be all good. So I'm doing that anyway, whether we have these platforms as a tile or not. Okay. Another thing that you can do is with the tiles we have right now, it's not really, well, I guess you could do it, but let's say you wanted a platform that moves from left to right, you know? I think the best way to do this would to be have actually that platform saved as an image file, and create maybe a class that can be put into the game objects array that updates and renders just like the map, or you can just put it as part of your map and have, you know, the tiles like we did before. So pretty much what I'm saying is what we're doing is we have kind of a happy medium between the two. We have the platforms array of platforms that maybe are just kind of like part of the level design, like a hill or something. Or like a mountain, like a square mountain, you know, where in like Super Mario World, where you jump between two areas, you know, stuff like that. So we have all of that kind of put together. I'm gonna go ahead and not save that, so we have just our platforms. So we're gonna have a happy medium between the two. We're gonna have both. You can both place tiles and have platforms. So let's go ahead and do that. So it's public map, background, and platforms. My eyes hurt from looking at that pink for so long now. Sorry about that, you guys. Splash platforms. That's why it's our alpha color, because nobody uses it. And now we need to go to game and pass in a new image, new sprite image for the platforms. And the platforms image is going to be the same size as the background image. So we're just going to render that with the same parameters. Make a space so it doesn't really get confused. Render platforms. What? Oops. Okay. No such method error. Game.java. That usually only happens if we didn't compile something. There we go. Okay. So as you can see, the platforms are rendering, and now what we're going to do is make it so you actually land on the platforms. And let's see, how far are we into this video? We're at 57 minutes. Well, this is kind of I don't feel like we've fully implemented platformer right now, so we're actually going to do this now. So I don't have notes on this because I wasn't expecting to do this in this video, but I think it's very important for you guys to be able to implement this now, and I don't not have to wait for me to upload a new video. And since I have time, we're going to do that now. So anyway, that was a very long-winded explanation. First thing we're going to do is actually going to re-implement the whole tiles thing we had. So let's go ahead and open up our tiles.txt here. Now, our tiles.txt, how we had it before, was we had it so that let's go ahead and open our tiles. We already had the sprite sheet, and it just gives the x and y coordinate of the tile because each tile was the same size. Well, we're going to go ahead and not do that, and instead what we're going to do is we're going to have tile file, so like the file name, and or tile name, sorry, what we'll do, tile name, file name, okay? That's all we're going to do. So we're actually going to make this a little bit organized, we're going to make a folder called tiles, or platforms, or whatever you want to call it. And in here, we're going to go ahead and put like our tiles. So let's go ahead and make a quick tile. We're just going to file new. The width is going to be 128, and the height is going to be 64. And this is going to be kind of like a basic platform. That's a terrible color. I know this. I know I'm kind of rushing this video, but that's orange color. Yeah, you guys, this game's gonna look terrible, but your game will look better because this is a game design tutorial, not art design, which should be, but you know, I'm not good with that kind of stuff. So anyway, this is gonna be just a basic, or let's call it basic platform.png. And we're going to save that. And by the way, if you actually just want to download these files as they are, you can download them from the workspace folder. That will be on my website. But, yeah, I'm not sure if you want to do that or not. Or at least they can be prototype assets, but I would not use them in your game. Yeah, I gave you permission to, but yeah, that's probably not the best idea. Anyway, so we want to go to, well, let's go ahead and implement it here. So the tile name is going to be basic platform, and the file is going to be basic platform.png, and I'm going to make it actually in the tiles class, so it picks all the tiles from the tiles folder. So I'm not going to actually put tiles / basic platform.png. So anyway, let's go ahead and open tiles because we have some stuff to change there. Where's tiles? Let's open that up. So what we want to do is, instead of taking a sprite sheet, we just want the tiles file. Okay. So once again, we are changing a bunch of stuff, so I would have made sure you made a copy of all this way beforehand. So we don't want to do anything with a sprite sheet, and oops. And that's it. Okay, so each tile is going to have a sprite still, but we're going to be getting that sprite differently. So first of all, we need a way to actually load images. So what I'm going to do is I'm going to go to game, and I'm going to make a load image a public method. And in fact, you know what? Let's go ahead and make a public sprite load sprite method, which is going to take a path, and then it's going to return new sprite of load image path. Okay. That didn't work. Oh, tiles has changed. So we're going to take game file tiles file, which is still the same. And then down here, the tile name is the first parameter. And then the second parameter, yeah. So we're going to get rid of this, and instead of the sprite sheet stuff, we're going to have sprite tile sprite is going to be equal to split string 1, which is the second parameter here. We're going to do game.load sprite split string 1. Okay? So we pass in tile name and tile sprite, and then we add the tile. So now what we're going to do is go to game and pass in this as the first parameter, and then the tiles file. So that's how we're going to load our tiles, and that is actually all we need to change in tiles. I know it's, oh wait, no it's not, I'm an idiot. Not really an idiot, but you know, sort of an idiot. So here is what we needed to change, because, no, you know what, I'm a smart person, I'm a really smart person, I've done a 180. No, I'm not really, but it just renders the sprite with the width and height of the sprite, and since the width and height of the sprite is different than 16, what I thought was the problem was, just to explain myself, was that render sprite was going to render a 16 by 16 tile, because that's all we had implemented before, but no, sprite.getWidth and sprite.getHeight is going to be the width and height of the image that we load, so yeah, that's fine. So tiles is done, and we are probably going to want to pass that into map soon. But the STK, we can actually re-implement this now for all of the sprites. And let's just see what happens if we do this. I have a feeling the tiles are going to look really different in the... oh, this is still needs to be commented. I have a feeling the tiles are going to look really different in the SDK. Or it could just crash. That too. Game.java 131, tiles.java 23. Oh! Load sprite, and it needs to be tiles / plus split string. Or was it lowercase tiles? No, it was uppercase. Okay. There we go. Oh my gosh. So that's the tile we have selected right now. So, yeah, what we need to do is, I think... okay, what we're gonna do is go to our SDK button, I think it was, because that's... Where's SDK button? There it is. Let's open that up. And... okay. The rectangle is actually what we're creating over here. So, we're gonna make the rectangle 16 times X zoom. We'll make it, instead of 16 times X zoom, it'll be buttons, or sorry, not buttons, it'll be, tiles sprites, I dot get width times x zoom, and then tile sprites I dot get height. Wait, what? What was the? Wait, so that's a Y? I'm confused. Why is that there? Make it 2. Which is 0. I don't get that. I guess I'll might probably be answered soon, but we're gonna make that get height times y. Sorry that I had to kind of like a brain fart there for a second. Okay, woo! That is our rectangle and tile has to key. That is huge. Oh my gosh. Okay, so now I guess the thing we need to do now is just make it all smaller. So render rectangle interface rect. Maybe we just make the whole thing smaller. Maybe we just go ahead and get rid of x zoom and y zoom. And then if we do that, we also need to render the thing. We'll just go ahead and make it 1 here. And then get rid of this part. Sorry, just look at what I'm doing. Sorry. I'm rendering this is the rectangle part and this is the sprite part. I'm just gonna make the zoom 1. And then get rid of the dividing by x zoom and divided by y zoom thing over there. And wait a minute. Am I forgetting something? Rect.x plus interface rect.x. Alright, hold on a sec. What any of this stuff is. Interface.rect minus, we're gonna do sprite.get width divided by 2. And in here we're gonna do minus sprite.get height divided by 2. I'm not sure what I was thinking when I made that. It was the GUI video, so I was probably just really really tired or something. I don't know, man. What else if we do that? That should. Oh, it's off the screen now. Should look at that. Did I not compile it? Wait, we just. Oh, that's the problem. Okay. We need to add like let's do like 5, 5. We need to add padding is what I'm trying to say. By the way, you don't have to do any of this. This is mostly just graphical stuff anyway. I'm just gonna hardcode it. Because this isn't even for the person who's playing the game. This is actually just for us building the level. So now we have a little bit of, no we don't. Oh, I know why. I'm gonna actually add 10 here. Okay, so now we have a little bit of padding, and we can select that tile, and we can't place it yet. That's the next thing we need to do. So if we go down to where we did have map.set tile and map.remove tile. Well, actually, we have to. Okay, we have to pretty much re-implement map now. So this is the hard part. So if we go ahead and look at our old map here. There we go. Tie those together. We had a map file as well, so we need to actually still load a map file, but things are going to change a little bit. Just actually not too much, but we're also going to copy in map to tile. Most of this is going to be copying and pasting now. I just found it easier to start completely from scratch and just copy things in. So we're still going to have the tile ID and we're still going to have X and Y. But the X and Y are not going to be the tile X and Y on a grid. It's going to actually be the actual X and Y position on the screen. So we're still taking in a map file here. And we actually do need a set of tiles as well. So we need tiles, tile set. So private int or tiles tile set. We're going to go ahead and set this dot tile set equal to tile set, and then we can get rolling here. So, and then we also want to, because we want to save the map file as well. so we can save the map later. So this dot map file equals map file. Okay, so go to our old map here and copy everything that's surrounded in this try statement. This entire try statement. We're going to move one thing though. We don't have a fill tile anymore, so we're going to get rid of that part, and now we just have the first line in this if statement should be the split string line. So, and then this is going to be the same because we're just adding new mapped tiles, and all the parameters are the same. So, yep, that's it. And we're saving. Oh, we're saving the comments. We need both of these lines right here. Private. We need to map. We need to map the tiles, and we also need the comments that were in the mapped file. So we're going to go ahead and import array list hash map. We also need to import. We need to import all of this. So go ahead and just copy in the imports from your old map. And now let's go ahead and make the set tile, remove tile, and save map method. So we're going to go ahead and copy all three of these methods, but we are going to have to change a few things, just not too much. So paste. Now let's go all the way up here. Set tile, tile X, tile Y, and tile ID. If found tile equals false. So the interesting thing we have to do here is not all the map tiles are the same size, and we're no longer dealing with a grid. So we actually have to kind of create two. We have to see if the mouse intersects with the region for each mapped tile, and if it does, that's the map tile we're talking about. Okay. So the way to do that is actually to create a rectangle which represents the yeah, sorry. That's for remove tile, not set tile. I'm getting ahead of myself. This is actually very easy. I'm going to delete all of that. Alright? What we're actually going to do is add a new mapped tile with just the tile ID, the tile X, and tile Y. Set tile is really easy, as you can see, because we're not dealing to see it. What the problem before was that we had a grid, right? And we had to make sure there wasn't a mapped tile in that grid position, because if there was, we want to actually just replace it. So instead of layering on top of each other, because that creates problems. So now we're going to go to remove tile, and we're still going to loop through all of the tiles, and we're going to grab the mapped tile there. But we can't just see if the X is equal to the tile X and the Y is equal to that Y, because we're dealing with exact coordinates and not grid coordinates. So I'd have to click on the very top left of each platform to remove it if this were the case. But we're actually not going to do that. What we're going to do is we're going to go ahead and create a rectangle called mapped tile rect, which is going to be equal to new rectangle, mapped tile.x, mapped tile.y, and the width is going to be the sprite, the mapped tile sprite, which actually might just be easier if we create a public, just a variable here. Forget the name for this type of variable, but tileset.get sprite mapped tile.get ID. Do we have that method? Do we have that method in tiles? I think we do, don't we? Oh, we have get sprites, but not get sprite. We want to have a public sprite get sprite int tile ID. And if tile ID is greater than or equal to 0, and tile ID is less than tiles list dot size, then we want to return tile list dot get tile ID dot sprite, and otherwise we want to return null because it means that we were out of those boundaries. And now we want to go to map. I want to get sprite for that tile, and yeah, that's where we stopped off. So the width is going to be sprite.getWidth times x zoom. So we actually need to get that somehow, and I feel like we can just get that by parameters, which we'll have to put in because we're calling this method from the game class anyway. So x zoom, or sprite.getWidth times x zoom, and sprite.getHeight times y zoom. Alright, so that is our rectangle. X, Y, sprite.getWidth times x zoom, sprite.getHeight times y zoom. And now we need a rectangle for the mouse. So rectangle mouse is going to be equal to a new rectangle tile X, tile Y, which is where we clicked, 1 and 1, okay? So pretty much what we've done here is we've got a rectangle that represents the mouse, and we've got a rectangle that represents the tile, and actually the rectangle that represents the mouse, for efficiency's sake, we can just create outside of the for loop, because that's not going to change. And all we need to do now is we need to go ahead and do mouse, if mouse dot intersects mapped tile rectangle. Now remember, we actually did make the intersects method, and that method we used, I believe, for SDK GUI. So yeah, that's a cool method. It's got a lot of uses, and here's one of them. So if mouse dot intersects mapped tile rectangle, then we want to remove this tile. So we want to do mapped tiles dot remove. Hold on. Mapped tiles dot remove I. And we also want to break, because you don't want to move any more tiles if there are other ones behind this one. So that'll break this for loop so we don't remove any more tiles, and it'll also do return, which I guess we could just make this return and it would do the same thing. Break and return in this case would do the same thing, because that's the end of the for loop. We're going to make return so we know exactly what's happening. And now let's go ahead and fix some problems. Cannot find symbol tiles, not tile. Rectangle mouse cannot find symbol rectang. Rectangle. Cannot find symbol fill tile ID, because that doesn't exist. We haven't done save map yet. Okay, so save map is going to change as well. Save map actually should be a decent amount easier. Well, the only thing we have to remove is fill tile. So once we remove that, everything else is the same. Because we have the comments, we have tile ID, tile X, and tile Y. So there we go. Cool. And now we need to go to game, and this isn't going to compile. Because we need to change the parameters on set tile. And also we need to change some parameters when we load map. What extra parameters do we have? We have the tile set and the map file. So we just need to pass in tiles, and then also new file map.txt. Was it lowercase? Oops. It was uppercase. Close out of these windows that I accidentally opened. Okay. Alright. So now if we click, nothing's going to happen because we haven't uncommented those methods. Map.setTile, X, Y, and that's all we need. Map.removeTile, we also need the X zoom and Y zoom. And there we go. Alright, so now if we select this tile... Oh? Yeah, we're not rendering the tiles. Oh boy, you know, it's been one of those days. It's been one of those days. Let's go ahead and figure out how we did that before. So, oh yeah, that was for the fill tile. That was a little harder, but we're gonna copy this lower part after we render the background. So for tile index equals 0, tile index is less than map tiles.size, tile index plus plus, map tile equals map tiles get tile index, and then we are rendering that with, and here's the problem, we have x and we have y times tile width. We just want to have x and y because we're not dealing with a grid anymore. And then once we do that, the tiles should render. Now the cool thing, oh, tile ID 6 is not within range of 1. That is true, you are correct. I know what the problem is. This still exists. And we need to get rid of this and get rid of that. Okay? And now it's an empty map. Now we can place our tiles. Maybe. Okay, maybe it's just a problem with the rendering. Let's try 0, 50, 50. Oh! It went away. Why'd it go away? Why'd you do that? Let's make this bigger. Tiles not that render tile. Zoom and Y zoom. remove tile. Was remove tile getting called for some reason? Let me right click, be remove tile. This is weird. Okay. Let me just think about this. So weird. Okay. First, another thing we have to do. The reason that's happening is because our selected tile ID was 2 by default. We're gonna set it to -1, so we don't have anything selected by default. Alright. I'll figure this out. First of all, I know why this was happening. This was happening because that was way up there, and when the player updated, that went away. And the reason why this isn't working is because we are dividing. We're getting the position on the screen. And then we're dividing by 16 times x zoom. We actually just want to divide by x zoom and divide by y zoom. And we have to do the same thing for up here. Just divide by x zoom and divide by y zoom. Because our tile sizes, we're not like getting it on a grid anymore. So, and that still didn't fix it. I could have swore that was the problem. I really could have. Maybe we just don't even divide by x zoom. No, we don't, because it's just the exact coordinates on the screen. Yeah, it's not even x zoom or y zoom. So now maybe that'll work. There we go. Okay. So you place by left clicking and you remove by right clicking. Let me just go ahead and do something quick just so I don't get too confuzzled here. We're going to open up paint.net here. I'm going to go ahead and add a quick little border to this image. Rectangle. Brush width 2. And there we go. So now if we run this, that's updated. And now here's the thing I want to change. We've layered these all on top of each other, right? These are all layered. But when I right click, it deletes the first one. Very easy way to fix this. Because we're looping through the list in order, the very easy way to fix that is to go to map and then go to set tile. And when we set the tile, I just want it to add it to the beginning of the array. So we just put a 0 as the first parameter, and it adds to the beginning. And now if I layer all these... No. Sorry. Got that wrong. What we actually want to do... What am I doing? Over here. Is we want to loop through mapped tiles the opposite. So, doing this without notes, sorry. Y is less than or greater than 0. Ooh, I minus greater than or equal to 0. I equals map tiles dot size and -1. I is greater than or equal to 0. I minus minus, and that'll loop through. Whenever we call the remove tile method, that'll loop through the array backwards. So, in the order that it's rendered. So. Save. Control S saves. And those all should have been saved in map.txt, and they weren't because I commented out the method here. Alright. Save. Control S saves. And there they all are, all those random tiles. And if we run, it should all be there again. There we go. Now the beginning, it kind of glitches out. What we can do to solve that is... the update camera, this is getting called before... Well, we could always just start the camera position where we think it's going to be. I'm not going to worry about that for now. That's not that big of an issue. We're going to get into actually making this... Oh, oops, tile... Okay, you know what? Select the tile, make that 0. Otherwise, you're going to have trouble with that. Make sure you always have at least one tile selected. Alright, there we go. I like what we got going on here. So, the next thing is going to be raycast. Oh, you know what? I just thought of something. Whenever I place a tile, it's going to start. I can click anywhere on the tile to remove it, which is cool. But it's always going to be at the top left. I feel like that just feels weird. So what we're going to do is we're going to go to set tile and going to be tile ID plus tile X. Okay, what we need to do is get the sprite for that tile ID. So we're going to tile set dot get sprite tile ID. I'm going to go ahead and do tile X plus Oh, sprite equals tile x plus sprite dot get width divided by 2, and then tile y times or plus sprite dot get height divided by 2, and we also actually need to take into account zooming, which means that we also need x zoom and y zoom here. All right, times x zoom times y zoom. And now we can go to game, go to where we're setting the tile, which is here, pass in x zoom, y zoom, and then I'm gonna save the map like this. Save. When oh, that's not what I wanted. Maybe it's not taking into account zoom. Oh shoot. Let's try getting rid of zoom here. Because it takes into account zoom later. Well, I don't know. It's weird. No, maybe I got this entirely wrong. Sprite.get height and get width divided by 2. I'm trying to, if you're wondering what I'm actually trying to do, I'm trying to offset it so wherever we click, oh, it's minus, obviously. What am I doing? It's probably, let's try implementing zoom again now. Because it's the top left and I'm subtracting it so that wherever we click is where the middle of the tile is placed. That's what I'm trying to do. So if I click there, yes, there we go. Now it feels a lot better. So wherever we click is where the middle of whatever we're trying to place is placed. So there we go. So next we want to do is we want to render for whatever's on the screen. We want to render this to and like a separate almost array of pixels, right? All of these platforms, and not just the platforms we have in platforms.png, but also the tiles. And then we want to do raycasting, which is, as I said, takes the whole map we have, and I'm actually going to show you guys this in a kind of like, here, let's copy this to clipboard, hey.net, boom, expand canvas, or yeah, expand canvas. And what raycasting is going to do is it's going to take wherever the player is. So if I move this player up here, for example, it's going to take wherever the player is, and then it's going to cast a line starting from the bottom of the player all the way to whatever platform's below it. Okay, so it's going to figure out what's below it. And then it's going to get the Y position of that platform. And what we're going to do is in player, I have so many of these open, I guess we don't have that open anymore. Okay, good, good. Glad that happened. Player. Okay, here we go. So in players update, Y min, which is currently set to just the bottom of the map, is going to be set to wherever that platform that below us is. So pretty much we can jump onto platforms, do stuff like that. The only problem that we're gonna have with this is, let's say the player, and we're gonna fix this from the get-go. Let's say the player is actually in the platform, right? And I know this kind of weird. I'm brute forcing this. Then when we raycast down, it's gonna get the pixel directly below the player, and the player's gonna kind of just gonna be stuck there, right? So the way we're gonna fix that is whenever we raycast and we're in a pixel. So let's say we raycast, and the point that is found should be like right there, except over here below the player. Then what we're going to do is we're going to work our way upwards then until we find the top of that pixel spot, and that'll be Y min, okay? And then we'll have to make sure we take account of the fact that Y min might actually be, the player might be under that, and if that's the case, we want the player to keep going until the velocity is going downwards. So we have positive Y velocity going downwards, and then we'll take account of that. So if we can actually jump through a platform if that's the case, and then land on top of it. So all of that stuff is going to happen next episode, because it has been long enough for this episode. So I will do that at some point. It's just getting late, and I don't want to try anything new without sufficient amount of notes. So anyway, guys, that's it for this lesson. I hope you guys enjoyed. Make sure to like, and the more likes I get, the sooner the next lesson will get implemented. In the meantime, you can try, if you want, exactly what I just showed you. For those of you that like a true challenge in programming, that is a good challenge. So, raycasting. The best way to do this, as I said, it would be to, and you have to do this in render. You can do this in update whenever the player moves. And whenever you want to calculate y-min, maybe make that a method in player or a method in map. And map can take into account both the set tiles and the platforms. And put that all into a array that is initially filled with the alpha sprite. So pretty much what you can do is you can create an array that's the size of the screen. So create an array that's this size, fill it with the alpha pixel, and then the alpha color, and then put in the platforms, put in the tiles, and then raycast. Okay, and the raycast will start from wherever the player's position is, and then go downwards, and so on. So that's a true challenge, and if you guys are up to that, you can try that out. I'm gonna make a separate raycasting video because I think like raycasting is a huge thing, not just for platforming, but for other types of games. So yeah, that's about it for this episode, guys. That's it. We got a lot done. Platforms are cool. Platformers are cool. You can set tiles, and the SDK GUI will change depending on the size of the sprite. I'm gonna stop talking now, guys. Thanks for watching.